Okay, so we've looked at some word problems and we've looked at linear patterns. Now we're going to kind of combine those two things into writing linear equations. So because a linear equation, most people think y equals mx plus b, which is one of the formats we can use for linear equations. These are two variable equations because you've got the y and the x. Usually with word problems, we use variables that are different than y and x, but it's the same idea. So I have an example here that we're going to go through. To rent a locker at an amusement park, there is an upfront fee of $3 plus a $2 per hour charge. Write an equation that can be used to find C, the total cost of renting a locker for H hours. So the first thing that we need to notice here is that they've told us which variables to use. And so when they do that, you need to make sure you're paying attention and that you do use the variables that were given to you. So in this case, C is going to be our total cost, H is the number of hours. So when we look at this, we have an upfront fee of $3, which upfront fee, this is something that you just are paying one time, not every single hour. Then every hour you're paying $2 additional. So if we want to say C equals cost equals, we have $3 cost plus, then we have $2 per hour. So for H hours, and if you don't know what to do with it, you can think of it, well, what if it were 5 hours? We can use that same strategy that we had used in the previous word problem video, in that if you don't already know what to do with it, you can say, well, what if it was $5? Well, I do 2 times 5, and then I've got the 3. So hopefully that helps you see that what you need to do is you need to multiply the number of hours times the hourly charge. This is a really common format for linear word problems, and that is to have something that's like a one-time charge and then a charge that, is monthly or yearly, or in this case, hourly, to add to it. So you just have to make sure that you're distinguishing what needs to be multiplied by the variable, which this word per gives you the hint that this one does, and what is just a one-time, doesn't need attached to the variable thing, which would be the 3 in this case. Another thing I want to address is that the format of this does not matter. If you wrote 2h plus 3, that is the exact same thing, and it does not matter which order you do that in. So here we want to graph the equation in the space at the right. So things with word problems, when they are real life situations and you are graphing, you need to make sure that you give your graph a title. So I would maybe just say locker rental cost. And then we label our axes. So this is going to be H. This is our number of hours. And I can't turn the paper here, so I'm just going to label it, kind of up and down. But this is our C axis, which means cost. So that was supposed to be an O. And that's in dollars. So you, of course, can turn your paper sideways, but I can't do that here. So, all right, so we've got our labels. We want to graph the equation. Now, we've already reviewed how to graph linear equations, and if it helps you to rewrite it with y's and x's, then go right ahead. Our y-axis is the same as our c-axis, so you could say 3 plus 2x is the same idea, which means that if you want to put it in y equals mx plus b form, would be y equals 2x plus 3. So if you want to graph it using slope-intercept, then you would plot the y-intercept and use the slope to get the additional values. So plus 3, if I'm just counting by ones, would be here, and then up 2, right 1, up 2, right 1. and it's hard for me to connect things without wiggling, so sorry that that doesn't look exactly like a line, but that's what we have here. You could, of course, graph by the other methods that we reviewed earlier this year. If you wanted to make a t-chart or wanted to find both intercepts, you could do it that way as well. I used slope-intercept because in the next question it asks us the meaning of the slope in the y-intercept. So our slope, which is 2, represents the per hour charge in dollars. The y-intercept, which is 3, represents the $3 initial one-time charge. Next, once we've got an equation written, we want to find the cost of renting a locker for 8 hours. So H stands for hours, so this one's pretty easy. We just need to take our equation that we had, and in place of the H, we're going to put in 8 because we're substituting that in its place. So that gives us C equals 3 plus 16, which would be $19. And we've already got our label there. Last one, Noah has $10 to spend on locker rental. Use your equation to find how many hours of locker rental he can afford. Show your work. So this one, you need to be careful, and that's why I've given you examples like this. Do not do the exact same thing you did here. 10 is not an H value, it's a C value, it's a cost value. So we're going to have 10 equals, and then the rest of the equation stays as it was in our original problem, 3 plus 2H. So now we can solve. We want to get H alone. So 10 minus 3 gives us 7 divided by 2. So when we solve this, we get 3.5. However, this says you get charged $2 per hour. And in most cases like this, that means that if you use part of the hour, you get charged for all of it. So Noah can't afford to pay for that 4th hour. He only has enough for 3 plus a little bit more. But we can't count the little bit more because the lockers don't work that way. They reset on full hours, which means that in this case, even though 3.5 exactly is what you get when you solve, the common sense part tells us that we have to make that 3 hours. He can actually only afford to have the locker for 3 hours because the 4th hour is going to cost $11 and he's just a little bit short. So hopefully that makes sense. Again, big things that are always true with word problems to pay attention to. Labels on axes and giving graphs titles, and then making sure you're paying attention when you're given values to make sure you're plugging it in for the right variable.